We just covered the case that works for law of sines where we have ASA or AAS, where those pieces of information are given where there are two angles and a side given to us. But now we're going to cover the one that's kind of the most pesky, and it takes probably 3 times as much time as that last one to cover everything, and that's the ambiguous case, SSA. And I haven't reversed it for obvious reasons. The problem is that this is one that was not able to prove triangles congruent in geometry. So there are just a lot of ways that these triangles can be drawn, and one of them is actually no triangles possible here. There's a way that we can line up these pieces of information so that there's not going to be a triangle that even happens. And that's going to be, well, you'll notice that there are 2 conditions for this, and I have the pictures drawn for each. You can refer back to these later on. This might be one that you go back to just to kind of picture what's happening here. But we're going to be given an angle. Now, it says angle A in this case. It could be B, it could be C. Don't get too hung up on the letters. Just know that whatever angle is given, we're going to put that in the bottom left-hand corner. At least that's what I do. Once we get that, then we line up the other pieces that go with it. Now, most likely, they're going to give us one side that goes with that angle, so we have that pair, but then they're also going to give us another side, in this case B. So we're going to have A and B, little a, little b is what I mean, big angle A, and then we are going to need to find out H, because what happens is that if this is our side that's given right here, we got to think about this as almost being on a hinge. That thing's going to swing down, and we got to make sure that it can actually touch this side. And as you can see by the way it's drawn here, it's not going to touch that side. It won't connect, and it won't make an actual triangle. This is if the angle is acute, as you'll notice from up here. Now, if the angle is obtuse, then we're going to not worry so much about the height. We're not going to have to find that height. We're just going to have to see, okay, yeah, this is kind of the same thing. If I were to swing this side, if this angle right here is on a hinge, it's going to fall flat, and it's really not going to work. So we are going to go through examples that illustrate this case. We'll go through one of each of the 3 cases. But one thing you want to do is you want to find, in the case of an acute triangle, you want to find the height first, and we'll talk about that when we're looking at our examples. The second case is 2 possible triangles. Now, I have an example that's taken directly from the book on page 436. So on page 436, you'll see this same picture if you want to go there. Now, this happens to be the case where if you find, so the same setup as before, we put the angle in the corner, but notice that this one is acute. We're talking acute only when we have 2 triangles possible. This is our most pesky case. We're going to find that height, and again, we'll do that in the examples, so you'll see what I mean by finding the height and how we do that with this setup. But then once we find that height, we're going to think about, all right, does this side over here, does this little a, does it reach down to the bottom? In this case, by the way it's drawn, clearly it does. It touches down, and it actually makes a triangle. The catch is that the height is going to be a little less than the 6, but the 6 is going to be a little bit less than the other side, in this case, which is a 7. So if I swing that side over, if this side swings over to there, then there's also going to be one spot where it touches down on this side, giving us 2 completely distinct triangles. And so we have 2 to deal with in that case, and we'll come to that conclusion on certain examples. I'll show you one in a little bit. But then there is one other last possibility, and that is if there's just 1 triangle possible. So when there's 1 triangle possible, that's going to be, well, first of all, it can be either acute or obtuse for these angles. And so, like before, I'm going to put that angle in the lower left-hand corner to start out when I draw my triangle. If A is greater than or equal to B, or A is equal to H, basically meaning if that other side that I have over here, like say this one again is on the hinge, if that side exactly matches up, then we have 1 triangle, and this happens to be a right triangle. If it's bigger than H, if it's bigger than H, it's also bigger than B, then what's going to end up happening is it's just going to contact over here somewhere. And so that's going to make one possible triangle. If it's obtuse, then we're talking about A being greater than B. So this side, if we're talking the hinge again right here and this is swinging down, this side will contact the base because it's bigger than B, and so it's going to reach there and it's going to make a triangle.